Yeah, so it's yeah. Welcome to our talk. The talk title has slightly deviated from what you saw in the description. We're going to tell you about how to enable an organization to be data-driven. I am a software developer at Booking.com on the online experimentation team. My team is responsible for allowing the whole of my company to run experiments on the various products that we have, not only the user-visible website, but the hotel-facing products and internal systems. Some facts about Booking.com. We are the world's largest accommodation provider. Over 1 billion guest nights booked. Over 1.5 million room nights booked in any 24-hour window on average, and 137 million reviews. So as you can imagine, all of these systems, the front-end sites and the review system and the customer care systems and all those, they produce a lot of data, right? And that's why we are here at Big Data Meetup. Before we move on to the meat of the talk, can someone guess how much data do we stuff into Hadoop? It's looking at these numbers, we are all good at estimation. How much data do you think in bytes?
Petabyte, cumulative?
Yeah, every day, oh, yeah, per day.
5 to 10 terabytes.
How 5 to 10 terabytes? How many of you think it's more than that? Less than that? Oh, rest of you. Okay, I share the answers. So we have not only Hadoop, we have Cassandra and systems that other systems that enable big data. We dump about 30 terabytes of data every day to Hadoop. 10 terabytes per day to Cassandra. We have now close to 2,000 coordinators in Oozie coordinators. We are heavy users of Oozie. And on any given day, we have about 50 to 80,000 applications in Yarn. The unreplicated, the total cluster size, total size of data that we have on Hadoop, unreplicated is to date about 25 petabytes. And we have factor of 3 replication, so that is about 80 petabytes. And that's just one cluster. We have multiple 2 clusters. So that's us. I think we qualify as a big data company with that. So that's why I'm here. So with any big data system, we are able to produce this data. And we are able to dump this amount of data in our warehouse. But then when you use one of these complex technologies, I mean, all of us are very well aware of the challenges that come with deploying and maintaining big data infrastructure. When we pay the cost of dealing with such deployments, we want certain guarantees out of those systems, right? And these are a sampling of those guarantees. We want the systems to be fault tolerant. We want the company, the business to maintain its day-to-day operations in spite of failures. And it's not just one machine failing in a data center, it's also an entire data center failing. We want to still continue. Clusters are not cheap, so we are a multi-tenant system. And then how do we ensure fairness in that system? How do we make sure a rogue query started by an analyst does not take down the whole cluster and cause delays for others' workflows? Security, very important. Capacity planning, someone has to actually sit there and buy new hardware, right, when your company grows. Those people are invisible but incredibly important. And tooling on top of the bare tooling what these systems provide you. Probably most of you are aware of this need of custom tooling on top of these systems, right? Now, as engineers, how many of you think we are able to nail any of this? Like, how many of you think any of this is easy or? Yes, so all of this is hard, right? And this broken formatting. So, Google Docs is also hard. So as we know, no one raised their hands. All of this is extremely hard already, right? Maintaining this technology is extremely difficult, and the cost of actually dealing with this, right, dealing with this difficulty, is offset only when you have more than a certain amount of data, right? You're actually doing big data. And if you can get away without using this, and if you can get away by using just MySQL and PostgreSQL, please do so, right? Don't want. So yeah, that's what we know. Big data tech is already hard. But from our experience at Booking, we've been doing this for a while. There's this other aspect, right? I mean, we are all technology people, and some of us even love to deal with this, right? Some of us even love to deal with these difficulties. But then there's another aspect of big data that is often overlooked, and in our experience is extremely important, is the organizational aspect. You can throw as much data as you want into your warehouse, right? But how do you enable your organization to make the most use of it? Right? Niels was telling us about a related topic. How do you enable data scientists and analysts to know what table do they need to use, and in what way should they join to get what kind of data? Right? To answer a question they have, where should they look? So in general, this is a problem, right? It's very important that people are free to people use their time in your company to answer questions that are important to them rather than deal with the infrastructure. So what we want at Booking, at least, is decentralized decision making. With the growing number of departments and teams that we have in Booking, and the increasing amount of specialization that each team has, we want each team to focus on their product area, right, and make decisions independently of other teams. But we also want knowledge sharing. We don't want one team to be completely in their own silo, and so that they're not aware of efforts along the same lines elsewhere in the company, or that they are not aligned with other teams in the company, and as a result not contributing to the mission of the company. So yeah, we want to enable decentralization, but then at the same time we want to tie these efforts together in some way, so that it doesn't end up in a chaos, an anarchy, right, or a mess. So the challenge is basically enabling a company to utilize the data in your warehouse is hard. So today, in Booking.com, we have various uses of big data, but I work on like I said, on the online experiments team, and I'll give you some examples on how we try to solve this organizational aspect of big data in the context of experimentation, right? And as a quick intro into that, I'd like to tell you why we experiment at all at Booking. The first reason is, of course, velocity. It allows experiments are easy to turn on and off, and then they allow us to move that much faster than complete releases. Who's aware of this term HIPPO? Who knows what that means? Lucas knows.
Hope you don't mean the CMS.
No.
Highest based person opinion.
Exactly. So HIPPO is highest paid person's opinion, right? Yeah. So we often see in some companies this is how development is done. The decisions come from top down, from the HIPPO, and no, we should change that button to yellow because that's my favorite color, and that's how it goes. But not at Booking. We are HIPPO-less, and which is why we want to empower everyone to run experiments, and that's one of the reasons why we run experiments, to validate hypotheses and not just go by hunch. The third reason is, of course, we prefer learning over just conversion optimization. You could optimize the hell out of an area, but then without gaining any learning or insights out of it. And running experiments allow us to learn about the area that we're experimenting on. That's why we experiment. So the challenge is, remember that we want to decentralize decision making and also tie this together. Right? We want to give as much control as possible to the teams, but also tie their efforts together. In the context of experimentation, this translates to some challenges. If you allow this kind of, just allow teams to do their own thing, what ends up happening is they create their own tables, which are redundant, right? I mean, teams may have overlapping data. They use that data to do their own analysis in their own way, right? And there might be bugs in those analysis that not necessarily the rest of the company might know about, right? And so each team essentially can have a very different picture of what the real world is, what the world looks like, right? And we are not moving anywhere if that happens. If teams just do their own thing and do their own reporting, we are not moving anywhere. Also, if we allow this, if we just have analysts do their own experiments and own reporting in their own Excel sheets, we have a very hard time learning from each other. Either you have to have a giant Google Docs folder where Excel sheets are tagged properly and people actually take the effort to take the time to search through.
AKA not happening.
What's that?
As in not happening.
Not happening, exactly. So yeah, we lose that if we allow absolute.
Probably the other way around.
Yeah.
Let me. I think it's like this.
Okay. And then the mic. Okay, perfect. Better. So yeah, so we want to. We lose this ability of learning from each other if we allow complete anarchy, right? So those are the challenges. And our approach that we have tried in multiple teams at Booking and also at the experiments team is can be summarized like this: diversify, then unify, right? We allow as much decentralization as possible, but then with a strong requirement that there is unification. Let's see concretely what that means in context of experimentation. So there are two aspects to experimentation: the who. Who is your visitor, right? When I come to your, let's say you are making, changing some part of our website, and I come to that part of the website, I'm your visitor, right? So who is, as you will see, the notion of a visitor at Booking is very general. So who a visitor is, and the other aspect is the what. What can we learn from this experiment? What is the visitor interacted with your change, and what did their behavior tell us about your change? And what did we learn about the world as a result of this experiment? So, diversifying the who. We allow, like I said, the notion of a visitor to be very general. We have abstracted the idea of a visitor. I'll show you an example. Let's say someone clicks on a Google ad or types in Booking.com and lands on a website, and then they see this page. On this page, we don't know much about the user. We don't know what their email is or whether they are a registered Booking.com user or not. They may not be logged in, right, at this point, or they may be a completely new user, or maybe they are using a private browsing tab, right? We don't know anything about them. So in this case, for us, visitor is an HTTP cookie. That's it, right? That's the best we can do. And this also means that if I'm looking at the site on my laptop and from my phone, then I am two visitors to Booking.com, right? Not one visitor. And it's impossible to, in general, resolve it to it being just one person, right? So in this case, a visitor is an HTTP cookie. But how about this? When we send a confirmation mail, and let's say we are trying to get it right? We want you to get the most out of your booking, and we are trying to get it right, and we're experimenting on the confirmation mail. In this case, we know your email, right? Because you gave it to us when making the booking. It's the booking email, right? So in this case, the visitor is the email address, right? Now we suddenly have a cross-device identification, because doesn't matter where you look at, on which device you look at your confirmation mail, it's your email, right? And it is sticky across devices. So that's how we make the idea of visitors very general, and there are a bunch of visitor kinds that are implemented at Booking currently, and new teams are free to extend this notion of visitor to whatever identifier they are comfortable experimenting with. Now that was diversification. That's how we allow teams to extend this notion of visitors and create new visitor types without us tying them down to one kind of visitor. How do we unify this? We provide randomization as service. So if you know much about A/B testing, the way it works is when a visitor comes to your site, you take a fair coin, you flip it. If it's a head, you show them the base, the current size as it is, and if it's a tail, you show them the variant with your site with the change. This coin has to be fair, and people. Any given visitor must have a 50% chance of landing in base and variant, right? It has to be fair. Otherwise, the results of the A/B test are invalidated. So because this is such a crucial aspect of A/B testing in general, we provide this as a service. And we even have checks in place to make sure that this distribution, this 50-50 distribution, doesn't drift, right? If it does, then we flag it as a data quality issue, and we don't allow decisions on that experiment. So that's how we unify the who. So next is the what, right? How do we deal with the what? First aspect, we have many concurrently running independent experiments, right? Like I said, you have multiple teams, one working on the maps, one working on some area of the site, one working on the search button, and they should be allowed to run experiments independently of each other, right? Because they are responsible for those areas, and we don't want interference. And indeed, that's what we do. As you can see, there are experiments at any given time running on, this is the hotel page, the hotel detail page. And there are experiments running on multiple areas of this single page, and in general, all of Booking.com. And these are all separate teams doing their independent thing, right? And they don't need to have approval from each other before starting their line of experiments. Of course, we have checks in place where experiments do indeed interact with each other and could be influencing each other's results. So we have those checks in place also that we flag those issues. The next way we diversify the what is teams can choose their own custom metrics. Now, imagine a product team that is doing work on this map here, right? Now, what they're interested in probably is, are people interacting with my widget? Do they find it useful? Are they actually looking at the map or doing something, right? So those are the metrics that that team is interested in. But consider the team responsible for customer care, right? Our customer service department. They are more interested in, are people canceling more because of some reason that we introduced this map? Are people canceling more because we are showing them the map? Or are they canceling less? Are they calling us less? Do we spend less because of this map? So those are the kinds of metrics that they are interested in. So in general, all these teams are interested in general, a different subset of metrics. And they're able to pick just those that they're interested in when running experiments. And not just pick from a predefined list of metrics. They're also able to define new metrics as they're able to tell us this is the metric that I'm interested in as a declarative Hive workflow, Hive query, and then we are able to aggregate it, as I'll talk about later. So yeah. Another way we diversify the choice of metrics is by having metrics which are local to your experiment, right? For example, the maps team. The team here is interested in interactions with the widget, which is a very local metric, right? Very local to your change. If this change turns out to be not good, then that metric has no value anymore. But then there are some metrics which are in general important for the company and for the business. like the number of cancellations, the bookings, of course, which are provided as global metrics, which teams can also pick. So unifying the what? We discussed that we are able, we give a lot of control to teams with respect to what metrics they can pick, and how that they can run concurrent experiments. To unify all this, we provide a common metrics aggregation as a service, a platform that allows you to say, hey, this is my metric, I'm interested in this metric, declaratively tell us via a Hive HQL query, and then we will do the aggregations for you. We will provide you that as a service out of the box. We have to make sure that people have trust in our data, because when you have so many teams and when you want them to make decisions independent of each other, and when you want them to depend on one set of ground truth data, you need to make sure that they have trust in this data. They trust this data, right? For which we have 2 independent data pipelines worked on by completely different people. One of them is real time, which gives you immediate feedback, and one of them is batch updates every day and runs in Hadoop, which is more accurate and has different purpose. It's these 2 pipelines are just able to do different things for us. And not only that, we have redundancy in each of these pipelines. So each of these pipelines are redundant in 2 clusters. So if one of them fails, we still are able to carry on. So this allows us to not only tweak things around in our pipelines, because if we screw something up, we'll see that these 2 pipelines are diverging. It also increases the trust that our teams have in the data that we produce, because we provide aggregation as a service. Then we have a central knowledge base, a set of tooling and reports that are built on top of this aggregation. Now, this is very important because, like we discussed, if every analyst has their own style of Excel workbooks where they do their own analysis and their own reporting, what might happen is they might use, for example, different thresholds for statistical significance, and different reports might show different. They might mean different things to different people. So we need to have this. We have this common UI, a common tool that everyone in the company is familiar with, and everyone is allowed access to. That shows reports in a consistent interface with consistent settings. And anyone is allowed to look up anyone else's experiments to draw inspiration from or challenge the learnings obtained in those experiments. So this is pretty important for us. This is where we finally tie things together by allowing people to make decisions independently, but then we have this common set of infrastructure and tooling that ties it all together. So with our solution, by diversifying and then unifying, we kind of obtain 3 things, right? First is teams can focus now on validating their hypotheses and answering their questions rather than worry about the infrastructure, the big data infrastructure, because that is what we abstract away for them. Also, an advantage is that if there is an improvement in the underlying aggregation systems, it is automatically available to everyone. For example, if you speed things up using Spark and you move away from Hive, it is automatically available to everyone. Teams can take learnings. Teams can learn from each other. Like I said, they can. Teams are focused on their product area, but then their learnings are not just owned by them. They are public, and they're public within Booking and visible to everyone. And this is one of our core values: is to fail fast, to try out ideas quickly, and to fail fast. And experimentation in this sense allows us to do that. If we had a complete decentralization, of complete anarchy, this wouldn't necessarily work the way it works today. And we've learned that not only having big data, producing data is important, but then providing these services on top for your company to make the optimal use of that resource, I think is also very important and often overlooked. So yeah, we go back to our problem that it's still hard to make your company utilize the data in your warehouse optimally. And we've been trying with these solutions to solve that, but there are still some standing challenges. The biggest is well, education. You need to when you build something and you want people to use it in a certain way, you need to educate them. And not only, there's this saying, a man convinced without his will is of the same opinion still, right? You need to not only educate them, but need to really convince them to that this is why we are doing it and why you should be on board with us, right? So education is a big part of what we do as a team. And well, debugging broken workflows. My metric doesn't work. It takes too long to compute and all that. But then, hey, the alternative was to have no metrics, or to let people be completely on their own, where they would either just give up, right? It's too hard, or they would be working with broken data, right? So I think we'll take this over that. And maintaining the infrastructure, of course, we all know, maintaining distributed, basically clusters of big data system installations is hard, right? And there's a lot of toil involved in there. So these are the challenges that we are still seeking to solve. But yeah, I think with our approach of first diversifying and then unifying, we have come a long way in enabling people to use the data that we have. And of course, in case you are wondering, we are hiring people, data engineers. Actually, we just opened this new position. Can't. No. So that's a new position that we've opened. Feel free to go to working at Booking.com and give us a try. And any questions you might have? Yeah.
The whole framework for collecting all the click events and user behavior in the browser, is it fully homegrown, or do you use any off-the-shelf solution for that?
The question was, is the technology for collecting user behavior in the browser, is it homegrown, or do we use any off-the-shelf solution? It's all homegrown. We've been doing experiments for how many? 14 years now. So yeah, it's all homegrown.
There were no off-the-shelf.
Yeah. Yeah.
You implied that your hardware is all physically maintained by local personnel. Why haven't you guys chosen for a cloud solution?
Well, we traditionally had a bias for insourcing because it just allows that much control, right? It just allows us to own certain things that we would not otherwise. And also, like Luca said, we've been doing this for a while, right? And at that point, there was no AWS that you can just use. But that said, we are kind of looking into using some cloud providers like Google to support some of our workload. But I don't think we are going to do away with our own data centers anytime soon.
What heuristics are you using to choose what services will become cloud supported and which ones will not?
From what I know, absolutely critical services will stay with us. and non-critical services that may not impact the site will, like ad hoc queries, for example, will move to the cloud because they have the tendency to throw everyone else's workflows apart, right? I mean, if you, like I said, we don't put restrictions on anyone. Anyone can just start up a query, and if it's a really horrible query, then it affects others, other critical workflows. So that's just one example, right? In the context of big data that we are looking at. Yeah.
How did you solve the security issue?
Well.
The security issue.
Yeah.
One security issue.
Yeah, well.
Yeah, well, we have none of them are here, but then we have big data teams that they're working really hard to get Kerberos integration, and also, as you might know, GDPR is coming next year. It's a set of regulations that requires you to be in control of your customers' data, and as such, yeah, we are Kerberizing our clusters right now, and there are teams working hard to do that. So yeah. It was not completely solved, but yeah.
How do you monitor all the AP experiments that you're running? For example, lately I tried to do a booking on Bookingcom, but it was kind of hard because I tried to use my credit card pre-existing, and then it said, well, you need to enter the CCP codes or something, which I couldn't fill in at all. So basically I couldn't even create a booking on Bookingcom. Do you monitor it all the time in a streaming fashion, or is somebody next day going to do an analysis and sees, well, something is wrong probably, or how does that work?
Well, so in that case, if you're not able to make bookings, right, we have fine monitoring in place to signal those issues, and it's usually a matter of minutes that someone responds to.
Well, I could make a booking by basically re-entering the same credit card in this case, so it's more or less well, probably less people will book.
Yeah. So in that case, if there's a significant drop in people who are able to book, right, then we are able to catch it fairly quickly, and within minutes people respond to it by. So yeah, there is monitoring. It's not like people are constantly refreshing dashboards to see something is wrong. There's alerting built on top, which tells us, which is very robust. So those issues are in fact indeed monitored and alerted on also. Yeah.
So before that, you have some queries from one person could affect other people. Whereas because they're very heavy, getting a long load for a long time. What kind of things are you doing there?
The question was some heavy queries from some users can affect others, and what sort of things are we doing around that? Is that right?
Yeah, sure. On the other hand, there might be some legitimate long-running queries. Right?
Sure. Yeah, but then yeah, we just do what the Hadoop fairness scheduler would do, right? Just kill. I mean, if it's an unannounced, unplanned query that if you know your query is going to be heavy, right? Then you would talk with the teams in question, and then they figure out a way for you. But then if you don't know in advance that your query is really heavy, then you would know because your query got killed, and then you would talk to that team. But then I don't think these queries, which are supposed to run for hours, are so critical that we really need to proactively make sure that they run. These are all ad hoc queries, right? I mean, I'm talking about ad hoc queries. Yeah.
You said that A/B tests are only valid if they're split 50-50 across the traffic. Why is that? Because you might have some more out there experiments which you only want to apply initially to like 1 or 10% of your visitors.
So what I said is, when you say your experiment is split by 50-50, you want to make sure, you want to basically give each person an equal chance to be in base or variant.
Yep.
Now, why is this important? Because let's say your coin is systematically biased for I don't know, Indian users and Chinese people, right? Indians and Chinese, and it's biased so that it puts more Indian and Chinese people into the variant, You will have more people there because there's more of us, right? And yeah. So what ends up happening is what you have tested in your variant is exposed is when the world had that % of Indians and Chinese people, and not what the real distribution is, right? So as such, if you were to toggle your experiment full on, you would not necessarily have the same impact as you observe. You would have. Does that answer your question?
The issue is not, he's asking whether the split needs to be 50-50, and your
Oh,
answer
okay.
is that it needs to be what you expected to get.
Okay, no. It does. Yeah.
You say 99-1,
Yeah.
and if you get 50-50,
Yeah.
then something's severe.
Yeah.
Yeah, but like, okay, so you need to make sure that whatever split you set up
Yeah.
is fair, but you can do custom splits.
Yes.
Okay, that makes much more sense. Yep.
Yeah. More questions?
So I have one. So you mentioned a bit like that the metrics are actually Hive queries. So how do you guys schedule this? Is it like is it just a list of Hive queries which are run consecutively, or how?
Oh, that's a good question actually. So the question is how do we let people specify Hive queries, and how do we schedule them in our workflow? So we have this core set of workflows which we call our pipeline, which computes the base metrics, if you will, like visitors to your experiments and all that. And then we allow people to specify these Hive queries as Oozie workflows, right? Wrapped within Oozie workflows. And each metric gets computed in its own workflow. Well, there can be multiple metrics, but it's up to the team. So what that means is these coordinators, they get scheduled as Jan would schedule them, right? As you have resources. And even if one workflow fails, it does not affect the computation of others' metrics. So if the team has a bug in the Hive code, we still carry on with the rest of the metrics and the base workflows.
Okay, thank you. So, and I have a follow-up question.
Yeah.
So you also mentioned that there's a streaming component as well. So how do you combine the streaming and the Hive, or is that yet another?
So we forgot to mention that we are Lambda-less. We don't do Lambda. So for those of you who don't know, Lambda architecture is when you have this real-time view and you have a batch view of data and you combine them. Usually the batch view takes precedence because it's more accurate. We don't combine these streams together. They serve completely different purposes. And one pipeline is able to do, while there is overlap, each pipeline is able to do something that the other is not able to do. So we keep them just there. And as a result, we have this side effect of making sure that our pipelines are in sync. And if we see discrepancies, we know one of them is wrong. We don't know which, but one of them is wrong.
Okay.
Questions?
Any more questions? I guess not. So let's thank the speaker.
Thank you.